Chapter 14, Climate. So the big idea for this chapter is that the different climates on Earth are influenced by natural factors as well as human activities. So we have natural factors, we do have human activities that influence climates. So Chapter 14, Section 1, Defining Climate. So the main idea here is that climate is affected by several factors, including latitude and elevation. So earth science for you. Just because you observe someone eating a steak dinner, you probably would not assume that they ate steak for every meal. In nature, taking a one-day snapshot of the weather does not necessarily describe what that location experiences over the course of many days. Now, before we go on, I want to mention that the numbers that you see on the side, like this 1 here and this 2, correspond to questions on your reading guide. So you can use those to kind of figure out where some of the answers are to the questions on that reading guide. So annual averages and variations. 50,000 years ago, the United States had much different weather patterns than those that exist today. The average temperature was several degrees cooler, and the jet stream was probably farther south. Understanding and predicting such climatic changes are the basic goals of climatology. And climatology is the study of Earth's climate and the factors that cause past, present, and future climatic changes. Climate describes the long-term weather patterns of an area. These patterns include much more than the average weather conditions. Climate also describes annual variations of temperature, precipitation, wind, and other weather variables. So you back up, describes the long-term weather patterns of an area. Studies of climate show extreme fluctuations of these variables over time. For example, climatic data can indicate the warmest and coldest temperatures recorded for a location. Figure 1 shows weather differences between summer and winter in Chicago, Illinois. This type of information, combined with comparisons between recent conditions and long-term averages, can be used by businesses to decide where to build new facilities and by people who have medical conditions that require them to live in certain climates. So some people, if they have bad lungs, for example, they may move somewhere like Arizona where it's dry and they don't have to deal with humidity all the time. So Chicago in the summer, it's sunny, there's no snow. Chicago in the winter, the lake is frozen over and there's a lot of snow, etc. in Chicago. Normals. The data used to describe an area's climate are compiled from meteorological records, which are continuously gathered at thousands of locations around the world. The data include daily high and low temperatures, amounts of rainfall, wind speed and direction, humidity, and air pressure. The data are averaged on a monthly or annual basis for a period of at least 30 years to determine the normals, which are the standard values for a location. So again, you have to have 30 years worth of data before you can actually call it a normal for that area. Limitations of normals. While normals offer valuable information, they must be used with caution. Weather conditions on any given day may differ wildly from the normals. For instance, the normal high temperature in January for a city might be 0 degrees Celsius. However, it is possible that no single day in January had a high of exactly 0 degrees Celsius. Normals are not intended to describe usual weather conditions. They are the average values over a long period of time. While climate describes the average weather conditions for a region, normals apply only to the specific place where the meteorological data were collected. Most meteorological data are gathered at airports, which cannot operate without up-to-date, accurate weather information. However, many airports are located outside city limits. While climatic normals are based on airport data, they might differ from actual weather conditions in nearby cities. Changes in elevation and other factors, such as proximity to large bodies of water, can cause climates to vary. Causes of climate. So you probably know from watching the weather reports that climates around the country vary greatly. For example, on average, daily temperatures are much warmer in Dallas, Texas than in Minneapolis, Minnesota. There are several reasons for such climatic variations, including differences in latitude, topography, closeness of lakes and oceans, availability of moisture, global wind patterns, ocean currents, and air masses. So those things all affect climate. Latitude. So recall that different parts of Earth receive different amounts of solar radiation. The amount of solar radiation received by one place varies because Earth is tilted on its axis, and this affects how the sun's rays strike Earth's surface. The area between 23.5 degrees south and 23.5 degrees north of the equator is known as the tropics. As figure 2 shows, tropical areas receive the most solar radiation because the sun's rays are nearly perpendicular to Earth's surface. As you might expect, temperatures in the tropics are generally warm year-round. For example, Caracas, Venezuela, located at about 10 degrees north, enjoys average maximum temperatures between 24 degrees Celsius and 27 degrees Celsius year-round. The temperate zones lie between 23.5 and 66.5 degrees north and south of the equator. As the name implies, temperatures in these regions are moderate. The polar zones are located from 66.5 degrees north and south of the equator to the poles. Solar radiation strikes the polar zones at a low angle. Thus, polar temperatures tend to be cold. Thule, Greenland, located at 77 degrees north, has average maximum temperatures between negative 20 degrees Celsius and 8 degrees Celsius year-round. Let's go back up and look at figure 2 real quick. So figure 2, latitude has a great effect on climate. The amount of solar radiation received on Earth decreases from the equator to the poles. So if you are near the equator, that would be like the first one here. This is your tropics. Okay, so the tropics, we have solar radiation that's coming in almost perpendicular to the surface. We get to the temperate zones. We have more of an angle. Here it's 45-degree angle hitting the surface. And that changes due to the tilt of the Earth on its axis. So throughout the year, this angle will change. It will get bigger and smaller. And this angle gets smaller in the winter, so the rays will be coming in at more of an angle in the winter. And then in the summer, they might be coming in at a more direct angle, so you'd have more direct sunlight. In the polar regions, we have the shallowest angle of all. Here we have 30 degrees. And actually, there's sometimes when at the poles, they go all the way to 0 degrees, and there's no sunlight at all. Okay, so anyway, so that's why how latitude affects climate. The further you get away from the equator, the steeper the angle, the light's coming in, and the bigger the area it has to be spread over, so the lower the intensity of the light. Okay. Topographic effects. Remember, topography refers to the shape of the land. So water heats up and cools down more slowly than land. Thus, large bodies of water affect the climates of coastal areas. Many coastal regions are warmer in the winter and cooler in the summer than island areas at similar latitudes. Also, temperatures in the lower atmosphere generally decrease with altitude. Thus, mountain climates are usually cooler than those at sea level. In addition, climates often differ on either side of a mountain. Air rises up one side of the mountain as a result of orographic lifting. The rising air cools, condenses, and then drops its moisture as shown in figure 3. So you have the a rainy side to the mountain, which is the windward side of the mountain. The leeward side of the mountain is drier. The climate on this side of the mountain, the windward side, is usually wet and cool. On the opposite side of the mountain, the leeward side, the air is drier and it warms as it descends. For this reason, deserts are common on the leeward side of mountains. So deserts are common on the leeward side of mountains. Okay. So again, this is just an example showing what's going on here. So you have the ocean out here. So you have air that has a lot of moisture in it. And as it hits the mountain, it has no option but to go up and over the mountain. As it goes up, the air cools, the moisture condenses, you get clouds, you get rain, you get snow at the top of the mountain. And then as this air mass comes over the mountain, it's lost a lot of its moisture. And you have a lot of dry air coming down this side of the mountain. So an example, in Hawaii, we have the windward side over here of the mountain. Then on this side, you have the leeward side. So on the windward side, you have all this vegetation. It's really green. On the leeward side, it's pretty barren. There's not a lot of vegetation on that side. All right, air masses. Two of the main causes of weather are the movement and interaction of air masses. Air masses also affect climate. Recall that air masses have distinct regions of origin, caused primarily by differences in the amount of solar radiation. The properties of air masses also depend on whether they formed over land or water. The air masses commonly found over North America are shown in Figure 4. So latitude determines if it's tropical. So we have tropical here, tropical here. If it's closer to the equator, tropical here. If it's polar, if it's closer to the poles, it's polar. Or if it's Arctic air. So latitude determines that. If it forms over water, it's going to be maritime. If it forms over land, well, if it forms over water, it's going to be maritime, and it's going to have a lot of moisture in it. If it forms over land, it's what we call continental. So continental air masses are drier air masses. Anyway, average weather conditions in and near regions of air mass formation are similar to those exhibited by the air masses themselves. Okay, so your average weather conditions in and near regions of air mass formation are similar to those exhibited by the air masses themselves. For example, consider the island of Dominica, shown in the corner of Figure 4 up here. It's not actually the bottom right, it's actually up here, and it's actually up here. So anyway, so we have all this lush vegetation, there's a lot of plants, etc. But anyway, so the island of Dominica, it's in the tropical Atlantic Ocean. Because this island is located in an area where maritime tropical, MT, air masses dominate, the island's climate has maritime tropical characteristics, such as warm temperatures, high humidity, and high amounts of precipitation. Okay, so I guess I should go ahead and do this real quick. You can have maritime tropical, you can have maritime polar, you can have continental tropical, you have continental polar, and then we also have Arctic and things like that. But these are the four main types of air masses. Now I mentioned the numbers, number 14 on your reading guide. Basically you need to put all this together to answer that question. And that brings us to the review questions down here.